Welcome to Spring LIB.
So in this question, we have a very complicated circuit as shown on the left side. In this circuit, no capacitor is in a simple parallel or series relationship with any other capacitors. So we cannot simplify the circuit into parallel and series. So what can we do? The question gives us this hint that assume a potential difference VAB exists across the network. Write the potential difference for various pathways through the network from A to B in terms of the charges on the capacitor and the capacitance. So let's try to think about different ways to go through this circuit. So we are at A. One path might be just here. So we have VAB equals C2 equals V2 plus V3 plus V4. A different path would be this. So it also equals V1 plus V3, V1 plus V2. And another path would be this. So it also equals V5 plus V4. And I think that's all we have. That's all three possible paths. And then there are also three independent charge relationships. So the total charge QAB. So this is a charge, and we can see from this branch QAB equals Q2 plus Q5. And it also equals, if we go this way, Q1 plus Q4. And another relationship exists in the middle if we want to look at it here. So we have Q2 equals Q1 plus Q3. You might argue that you can also say Q4 equals Q3 plus Q5. But that is actually duplicate with one of these relationships, because if you say Q4 equals Q3 minus Q5, or Q3 plus Q5, it is equivalent to saying, if we rearrange it, so we have Q4 equals Q2 plus Q5 minus Q1, and we know Q2 minus Q1 is Q3, then we get this relationship. So this is not, and we're not getting anything new from this equation. We only have three independent equations for charge and three independent equations for the voltage. So we will need to find the equivalent capacitance from these 6 equations. So firstly, because we do not know what Q is, let's try to write Q in terms of C and V. So this becomes C equivalent times V AB equals C2 V2 plus C5 V5. C equivalent times VAB equals C1 V1 plus C4 V4. And finally, C2 V2 equals C1 V1 plus C3 V3. Okay, now we have a set of 6 equations. Let me give some numbers. 1, 2, 4, 5, 6. Let me get a new color. So these are the 6 equations. So let's first try, we will eventually try to eliminate all the numbers that we do not want. Say from equation 2, equation 5, and equation 6, what we can do is we can say C equivalent times V equals C1 V1 plus C4 V4 1 V1 plus C4 V4. If we want to eliminate C1, what we can do is, instead of V1, we can say C1 times VAB minus V2. And similarly, this is number 5, this is number 6. C2 V2 equals C3 V3 plus C1 VAB minus V2. Okay. So what I was just trying to do is I'm trying to eliminate V1 from all these equations. So using this part. And then let's eliminate even more of the voltages. Let's say if I want to eliminate V5, so I can use number 3 to eliminate V5. So that's in equation 4. So C equivalent times V, I'll just write VAB as V for convenience, equals C2 V2 plus C5 V minus V4. So now we have 1, 2, 3, 4. We have equation 1, equation 4, 5, 6. Or this is a new 4. Equation 1 and equation 4, 5, 6. And all of them do not have V1 and V5 in them. But we can even eliminate more of these. Let's try also eliminating V3 using equation 1. And V3 appears in equation 6. So we can rewrite equation 6 out, put 2 circles on it, as C2 V2 equals C3 V minus V2 minus V4 plus C1 V minus V2. So let's rewrite this as C1 plus C2 plus C3 times V2 plus C3 V4 equals C1 plus C3 times V. Let me double check this is correct. C1 V, 2 C3 V2 plus C3 V4 equals C1 V plus great. Okay, so I will call this number 6. So now we have used 1, 2, 3 to eliminate 3 different voltages in 4, 5, 6. So we have gone from 6 unknown 6 equations to 3 unknown 3 equations, which is a huge progress we have. So now 3 equations we will be using is, this is 4, this is 5, and this is 6. And since that was getting a little bit messy, I will rewrite everything, because we still have a long way to go before we can finish this problem. If you do not follow, just go back a couple of seconds on the video and make sure you follow everything in the previous page. Okay, so 4, 5, 6. This is a previous page. And I'm just copying 4, 5, 6 to this new page. Okay, so Our ultimate purpose, of course, is to go from 3 equations, 3 unknowns, to 1 equation, 1 unknown, and we want to make sure the last unknown we have is the equivalent. But now we have 3, so let's just eventually use 1 equation to substitute the other 2, and then just keep doing things and simplify things. So we've eliminated v1, v3, v5. Let's try to eliminate v4. And v4 appears in all 3 equations. But let's try to use v4 from 4 to eliminate v5, v6. From 4, we have v4 equals c3 minus v2 minus v, actually plus, because there is minus sign in front of that, and here. That is v4, and then if we plug this into v5 and v6, into equation 5 and 6, we will get something very messy, but I will simplify them. So after I simplify both of them, 5 and 6 will become C5 C equivalent plus C4 C equivalent minus C4 C5 minus C5 C1 V equals C4 C2 minus C5 C1 P2. Because we have eliminated 1, 3, 4, 5. So the only two voltages we have left right now should be V and V2. C5, C1 plus C3 plus C3, C equivalent minus C3, C5. V equals C5, C1, C2, C3, C3, C2, V2. Okay, so what you should do is you should try to plug in V4 into V5 and V6 and simplify it and see whether your form matches mine here. And I grouped them by V and V2 because for the last step, what we want to do is we want to eliminate the variable V2 so that we only get the equation of the C1 to C5, C equivalent, and V. So that is the goal. So what we can do is we can use equation 5 to get V2 in terms of the other numbers, and we can plug them here. Or equivalently, we can divide V5 and we can divide equation 5 and equation 6. So that's why I grouped them so that V is on the left hand side and V2 is on the right hand side, so that the division is going to be easier. And so now I divide them, and I got an equation that is this thing divided by this thing equals this divided by this. So if you imagine this is a fraction, and this is a fraction. This is the equation I will end up getting. And we need to again simplify the whole thing. Finally, we get C equivalent on the left-hand side. And what we get, the result is actually quite messy. Plus C1, C2, C4 plus C1, C2, C5. So as you see, this question, it really isn't as easy as just simplifying the circuit, because you cannot simplify the circuit. C2, C3, C4 plus C2, C4, C5 plus C3, C4, C5. Whew. So that's just the numerator. We still have the denominator, which is C1, C3 plus C1, C4 plus C1, C5 plus C2, C3. It's pretty much just all possible combinations. Plus C2, C4 plus C2, C5 plus C3, C4 plus C3, C5. I lied, all possible combinations excluding C4, C5. But this is the equivalent capacitance of this whole system. This is really messy, this is really complicated, and make sure your arithmetic matches mine, because there are a million ways you can get this wrong. And finally, we plug in the numbers. Let me go back to page 1. We see C2, C4 equals 8, C1, C3, C5 is 4.5. Okay, I will not bother to write everything out. But if you really do just put everything into this equation, you will end up getting 6 microfarad.